What's up, guys and gals? My two gals, anyway. So you said you wanted to do actual Spike Prime stuff instead of something silly and maybe boring. So here you go. What we're going to do is we're going to do sort of two, maybe 2.5 things, depending on your time today. But wait, something very important and serious first.
3 of the hardest things for people to say: I was wrong, I need help, and Worcestershire sauce. Worcestershire sauce.
And so step 1 is going to be completely take apart your player, little player bot thing, and get all the pieces put away and sorted where they go, okay? And then once you have that done, then continue this video. So you'll just do that right now and pause this video. All right, so now that you have that done, then we're going to move on to the next task today. And the next task today is I want you to figure out the circumference of your Spike Prime wheels. And the reason you need to find the circumference of the Spike Prime wheels, that's these guys right here, okay, is because the hub, the Lego hub, actually doesn't know what size wheels you're putting on it. So when you tell the robot to go 84 centimeters, it's just moving the rotation of the wheels based on the circumference of the wheels. And so you actually have to tell the hub in advance what size wheels you have on. So that's your first investigation. I want you to get each of the wheels, the big one and the small one, and I'll plug a little discussion post in Schoology for you to post your thoughts. And tomorrow then I'll let you know which team or which of you got the closest accurate answer. But what I want you to do is figure out some way to find the circumference of those wheels. And if you don't remember what circumference is, then get on Google and figure it out. I'm not going to tell you. There's probably, I don't know, 3 or more ways to find the circumference of these wheels. You have some rulers in the room you can hunt down. There are all the centimeter tapes on all the lab tables. You can use those somehow to measure something. But I do want you to measure it in centimeters, so make sure you're doing that. If you happen to grab a ruler or yardstick / meter stick. And so make sure you're using the units of centimeters. Pause the video, and then you can come back to this once you have made your decision on what is the circumference of each of those tires. All right, so hopefully you got pretty close to that. When you do that, you need to be really, really picky and specific. Tomorrow we'll talk about what the actual circumference is and see how you did. All right, next step is we're gonna do a build. So we're moving on to an understanding of the movement motors. Right now we've been working in those blue motors, and now we're gonna be shifting to those pink movement motors where it's running 2 for a like car-based bot. And so what I want you to do is you are going to go to your iPad now and start doing a build. So I'll sort of walk you through that here. There's my iPad, it's a very low-tech version. And down here, I want you to go to build, and you need to have supplemental downloaded, which I think you all do, and you need to find Rhino bot right here. So click Rhino, and you are going to build Rhino's body and Rhino head, okay? You can work with a partner or by yourself, depending on how many hubs there are, but we might as well use all the available hubs, so you can decide how you want to do that. Go through. If you're working with a partner, one person can start building the Rhino body while the other person starts building the Rhino head, or however you want to manage it. But that's what he looks like in the end. And here's what your task is going to be. Notice these are the smaller size wheels as well. Your task is actually going to be to set this part of the bot, okay, like the white here, at 0 on your centimeter tape on your lab tables. And you need to drive this bot down the centimeter tape on your lab, on the lab table. And you're going to set up one Lego brick at 100 centimeters or 1 meter. Okay, so you're driving this bot, and your goal is to get the bot to, in one movement, start at 0 and drive all the way as close to that Lego brick as possible. Okay, in one coding. You can't get it part way and then code it more. Okay, and so get it as close as you can, pull it back, readjust code, run the program, and send it again. Okay, so I'll give you a little preview of what that code is going to need to look like, and then you can start messing around with that if you have time today. If not, that's what we're going to do tomorrow. Okay, so let's go ahead and take a look at code now. All right, in the Spike Prime app, I want you to go ahead and click New Project here, please. And let's go ahead and label this Rhino bot. And you can click Create. Okay, I'll go ahead and zoom in a little bit so you can see my blocks of code a little bit better. All right, so walk through the foundation of a driving code now, rather than just a motor-based code. What you're going to do is you're going to click this movement tab here, and we're always going to grab these last 3 blocks of code for the most part. We'll get into some details why you wouldn't later. So I'm going to pull out movement speed. I'm going to pull out what are the movement motors, and then I'm going to pull out this motor rotation. Okay, for those of you, which is all of you who already submitted your response, you'll see that the default motor rotation is 17.5. Not going to really explain what that means to you right now, but those of you who inputted some thoughts and ideas into the discussion post, that number might look close to something or somewhat familiar, and so maybe you can figure out why we have to have that number or block of code in there. Okay. You're going to want to mess with this movement speed. You don't have to do 50%. I actually would recommend not doing 50%. But you do have to set your movement motors according to what they are for your Rhino bot. So you have to look at what ports that they are. So one thing I want you to see is this A and B. This means the left wheel is in port A and the right wheel is in port B. So when you click on the A and B, you can see it pops up. If it's actually C and D, you just tap C, then tap D. If you accidentally reversed them, if I just click C, you can see it switches it to D and C. So if you're ever trying to drive straight and it actually drives backwards, that's why you accidentally have those mixed up. So I'm going to go ahead and make sure they say the correct ones. Like I said, I don't know what the ports are supposed to be, so set it according to what it's supposed to be for yours. All right, so those are the 3 foundational things. At that point, at this point anyway, I want you to just explore this movements category, and you can sort of mess around with what you want to bring down and just try some different things rather than me tell you what to do. Remember, your objective is to get your RhinoBot to start at 0 on the centimeter tape and then drive straight as close as you can get to that one. Actually, we need to put 2 Lego bricks stacked on top of each other, because that way if you hit it a little bit, it'll show that you knocked it off some. So set up 2 Lego bricks vertically on top of each other at the end of the meter or at the end of 100 centimeters. And then we'll see how close you can get. And this will probably be what carries you to tomorrow. And we'll continue this challenge. Make sure you watch the clock and clean up a couple minutes before 2 o'clock.